So guys, let us start with chapter 1, physics, class 11th, units and measurement. So let us talk about what is unit. So measurement of any physical quantity involves comparison with a certain basic arbitrarily chosen internationally accepted reference standard called unit. Now let's talk about fundamental or base unit. Although the number of physical quantities appear to be very large, we need only a limited number of units for expressing all the physical quantities because they are interrelated to one another. The units for the fundamental or base quantities are called fundamental or base unit. The units for the units of all the other physical quantities can be expressed as combination of the base units. Such units obtained for the derived quantities are called derived units. So complete set of these quantities, both base units and derived units, are known as system of units. Now let us move on to the international system of unit. In earlier time, scientists of different countries were using different system of units for measurement. Three such systems. So what are three systems? CGS, FPS and MKS. These three systems units were extensively used. So the base units for length, mass and time in these systems were as follows. So CGS system, they were centimeter, gram and second. Centimeter, gram and second. What was FPS? They were foot, pound and second. Foot, pound and second. This is centimeter, gram and second. MKs, they were they were meter, kilogram and second. So meter, kilogram and second. So in India, we are following this. Okay, we are following this. Also this in certain cases. But generally, we follow this now. What is SI unit? What is SI unit? The system of units which is at present internationally accepted for measurement is called as SI unit, or in French Système International des Units, abbreviated as SI. So these SI unit concept was brought forward in 1971 and they are recently revised in 2018. And what is the committee? General Conference on Weights and Measures. So it is revised by General Conference on Weights and Measures. International usage. Because SI units used decimal systems, conversion within the systems are quite simple and convenient. We shall follow the SI units in this book. Okay. So in SI there are 7 base units. What are those base units? Let us write down the base units. What are 7 base units? So first one is length, second one is mass, third one is time. So I'll just write the units. So length is meter, mass, that is kg, time, that is seconds, then fourth is electric, so it is ampere, then thermodynamic temperature, this is in Kelvin, then amount of substance, that is mole, and seventh one is luminous intensity, so that is CD, candela. Okay, so these are 7 base units: length, mass, time, electricity, thermodynamic temperature, amount of substance and luminous intensity. Now each of these base units have got different definitions also. So let us talk about meter. The meter symbol is M, is the SI unit of length. Okay, you can see here this is SI unit of length. It is defined by taking the fixed numerical value of the speed of light in vacuum to be 299, 792, 258. Okay, so the speed of light is taken as this when expressed in unit meters per second. Okay, where the second is defined in terms of cesium frequency, delta V Cs. So this is what is meter, length M. So this is what is meter as SI unit. Now the next is mass. So what is the definition? The kilogram. The symbol is kg. Symbol is kg. It is defined by taking the fixed numerical value of Planck's constant h. So there is something called Planck's constant. And what is the value of Planck's constant? 6.6 2 into 10 to the power minus 34 joule second. So when we talk about mass, we have to associate it with Planck's constant, that is h. And what is joule? So joule is kg meter per second square and into second. So what it becomes? Kg meters per second, where this meter and second are defined in terms of c, that is speed of light, and delta V, that is frequency of cesium atom. Now what is third? The second symbol S is the SI unit of time. It is defined by taking the fixed numerical value of cesium frequency, delta VCS, the unperturbed ground state hyperfine transition frequency of the cesium 133 atoms, to be 919263177 when expressed in the unit hertz, which is equal to per second. So we are taking this cesium element, and the frequency of cesium in hertz is 919263177, and this is per second. Hi guys. So the next is electric charge. So the next is electric. SI unit is ampere. The ampere symbol A is the SI unit of electric current. It is defined by taking the fixed numerical value of elementary charge E, that is the charge on elementary charge E electron is 1.6 into 10 to the power minus 19 coulomb, which is equal to ampere into second, where second is defined in terms of delta nu cesium element. Next is thermodynamic temperature, that is Kelvin, which is represented by symbol K. It is defined by taking the fixed numerical value of Boltzmann constant K to be 1.38 into 10 to the power minus 23 joule per Kelvin. This is Boltzmann constant. So basically what we are doing to define these values, we are taking some constant, let's say Boltzmann constant, okay, this is Planck's constant, this one is Planck's constant, okay, this is transition frequency of ground state cesium 133 atom, okay. So these are all constants which we are taking, and with the help of these constants we are trying to get the basically defining these terms, okay. Now the next is amount of substance, that is mole. What is amount of substance? 1 mole contains exactly 6.022 into 10 to the power 23 elementary entities. So now we are comparing, or we are taking the help of Avogadro's number. So what is that number? It is 6.023 into 10 to the power 23 atoms. Okay. So to define this mole, we are taking the help of Avogadro's constant. So this number is fixed numerical value of Avogadro constant Na. So it is also represented by Na, Avogadro number, when expressed in unit mole unit, that is per mole, and is called Avogadro's number. The amount of substance, symbol N, of a system is a measure of number of specified elementary entities. An elementary entity may be an atom, molecule, an ion or electron, or any other particle specified in Decopen. So these elementary entities can be, it can be atom, it can be molecule, it can be ions, right? And it can be electron also, okay. So there can be numerous elementary entities which can be associated with this Avogadro's constant. Now the last is luminous intensity, that is candela. It is defined by taking the fixed numerical value of luminous efficacy of monochromatic radiation of frequency 540 into 10 to the power 12 hertz. So the definition means candela measures how bright a light source appears in specific direction, okay. So it is based on a fixed reference, that is monochromatic radiation of frequency 540 into 10 to the power 12 hertz. This is the monochromatic radiation frequency. This corresponds to green light. Okay, this frequency corresponds to green light. What are the key points? So we have luminous efficacy. So we have luminous efficacy, which is represented by KCD, and is equal to 683 683 lumen per watt. It means that 1 watt of radiant power at that frequency produces 683 lumens of visible light. So it means 1 watt of radiant power at that frequency produces 683 lumens of visible light. This is the so luminous efficacy is lumens per watt. Candela refers to steradian because intensity is directional, right? So candela relates to steradian. Steradian is a type of angle, you must be aware. So it becomes equal to, so the the unit becomes equal to SCD, steradian per kg, per meter square seconds cube. So this is the, so these are basically the general idea of what luminous efficacy or luminous intensity is. So these values mentioned here need not to be remembered or asked in a test. They are just given here to indicate the extent of accuracy to which they are measured, right? So with progress in technology, the measuring techniques get improved, leading to measurements with greater precision. The definitions of base units are revised to keep up with this process. Okay, uh, so you don't have to remember each and everything. So this is just a brief of what we have studied today. Okay, and just read it once. Only thing is which constant is related to which unit, that you just remember. Okay, that will be enough. Values and all those things are not required as of now, right? So the next topic we will be taking is significant figure. This we will be taking tomorrow, right? So this is class 11 CBSE series, and every day we will be taking this kind of series. Okay, so just stay tuned and keep practicing. Thank you.